In the last class, we discussed about exercise 3.1 in the chapter 3, playing with the numbers, and today we are going to study about exercise 3.2. Then, so there are 12 more questions. Let us see how can we solve the questions. Okay, so the first question in exercise 3.2 question, exercise 3.2. First question is, what is the sum of any two A, odd numbers, and B, even numbers? There are two sub-questions in question number 1. That is, what is the sum of any two? First one is odd numbers. What is the sum of any two odd numbers? If we add any two odd numbers, then we get an even number. Okay, so the sum of any two odd number is an even number. The sum of any two odd number is an even number. So in question number 1A, the sum of any two odd number is an even number. That means if we add any two odd numbers, then we get an even number. And for example, 5 and 3 are two odd numbers. If we add 5 plus 3, then we get 8. 8 is an even number. Like this, if we add any two odd number, then we get an even number. So 1 and 3 are two odd numbers. If we add 1 and 3, then we get 4. 4 is an even number. Like this, if any two odd number, if we add any two odd number, then we get an even number. So sum of any two odd number is an even number. Okay. And in the question number 1, there are part B. What is the sum of any two even number? The sum of any two even number is also an even number. The sum of any two even number, the sum of any two even number is an even number. Is an even number. For example, 4 and 6 are even numbers. If we add 4 plus 6, then we get 10. 10 is an even number. So the sum of any two even number is an even number. And 2 and 6 are even numbers. If we add 2 plus 6, then we get 8. 8 is an even number. So we add any two even numbers, then we get an even number. Okay. So the sum of any two odd number is an even number, and the sum of any two even number is also an even number. That means if we add any two odd number, then we get an odd number. Sorry, even number. Then we add any two even numbers, then we get an even number. So the sum of any two odd number is an even number, and the sum of any two even number is an even number. And the question 2. Question number 2. It's a true or false question. There are some statements are given. So we can say that it's true or false. Okay. So state whether the following statements are true or false. And the first statement is the sum of 3 odd number is even. The first statement is the sum of 3 odd number is even. Say it is false, true or false. If we take any three odd numbers, that is 1, 3 and 5. Then we add these three numbers, odd numbers, 1 plus 3 plus 5. Then we get 1 plus 3, 4, 4 plus 5, 9. 9 is a odd number. So, and we take another question. 5, 7, 1. Then we add these three odd numbers, we get 13. So 13 is also a odd number. So the statement is false. So the statement is said that the sum of three odd numbers is even. So it is false because the sum of any three odd number is an odd number. Okay. So the first statement is false. And the statement B, the sum of two odd numbers and one even number is even. The sum of two odd numbers and one even number is even. Let us see. Sum of two odd numbers and one even number. Two odd numbers are 3 and 5 and take one even number, that is 8. Then if we add 3 plus 5, that is sum of two odd numbers and one even number, that is 8. So 5 plus 3, 8. Then 8 plus 8, we get 16. 16 is an even number. So the statement is true. The sum of two odd numbers and one even number is an even number. So that statement is true. And the statement C, the product of three odd number is odd. The product of three odd numbers is odd. Is it true or false? It is true. The product of any three, the product of three odd number is odd. That is 3 into 7 into 7 into 9. We get 189. That is 3, 7 and 9 are odd numbers and we get also an odd number. So the statement is true. And the statement D, if an even number is divided by 2, the quotient is always odd. So the statement is if an even number is divided by 2, the quotient is always odd. Is it true or false? If an even number is divided by 2, even if 8 is the even number, then 8 is divided by 2, we get the quotient as 4 2s are 8. So the quotient is 4. 4 is an even number. And here the state that quotient is always odd. It is false because here we divide an even number by 2, we get an even number. So the statement is false. Okay. So statement D is false. And the statement E, all prime numbers are odd. All prime numbers are odd. It is false. All prime numbers are not odd. That is, prime numbers start with 2. So 2 is an even number. So the statement is false. Statement D is false. And the statement A, prime numbers do not have any factors. Prime numbers do not have any factors. Is it true or false? It's false. Prime numbers are having two factors. That is 1 and the number itself are the factors of prime numbers. So prime numbers having two factors. Here the statement is prime numbers do not have any factors. So the statement is false. Then statement G, sum of two prime numbers is always even. Sum of two prime numbers is always even. Is it true or false? Prime number 2 and 3 and we get 5 is an odd number. So maybe it is an odd number. So the statement is false. Sum of two prime numbers is always even is the false statement. So statement G is false. Then the statement X, 2 is the only even prime number. 2 is the only even prime number. It is true. Except 2 other numbers, other prime numbers are odd numbers. Okay, so statement H is true. 2 is the only even prime number. Then I, statement I, all even numbers are composite numbers. All even numbers are composite numbers. Is it true or false? It's false because 2 is a prime number but 2 is not a composite number. Composite numbers start from 4. So the statement is false. All even numbers are composite number is a The product of two even numbers is always even. Is it true or false? It is true. The product of two even numbers is always even. We take the two even numbers are 6 and 2. Then we take the product by multiplying 6 and 2. We get 12. 12 is an even number. And 2 and 8 are also even numbers. Then we take the product of 2 and 8. We get 16. 16 is also an even number. So the statement is true. That is, the product of two even number is always an even number. So this statement is true. Okay. So once again repeated. State whether the following statements are true or false. And the first statement is the sum of three odd number is even. It is false. The sum of any three odd number is odd. Then statement B, the sum of two odd numbers and one even number is even. It is true. Then the product of three odd number is odd. It is true. Then if an even number is divided by 2, the quotient is always odd. It is false. If an even number is divided by 2, the quotient is even. Then all prime numbers are odd. It is false because all prime numbers are not odd. 2 is a prime number, it is an even number. Okay. Then prime numbers do not have any factors. It is false. Prime numbers having two factors, that is 1 and the number itself. Then sum of two prime number is always even. This is false. The sum of two prime numbers may be odd number. Then 2 is the only even prime number. That is true. Then all even numbers are composite numbers. That is false, since 2 is a prime number, which is an even number. Okay. Then the product of two even number is always even. That is true. We take the product of any two even numbers. The answer is also a even number. Also an even number. So these are the answers for true or false questions. And question number 2. Then move to the third question. In exercise 3.2. Question number 3. The numbers 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. 13 and 31 are prime numbers. 13 and 31 are prime numbers because 13 and 31 having only two factors. That is, 13 have the factors 1 and 13, and 31 have the factors 1 and 31. So these numbers are called prime numbers. And the question, both these numbers have same digits 1 and 3. Yes, 13 have the digits 1 and 3, and 31 also the digits are 1 and 3. And the question is, find such pairs of prime numbers up to 100. Find such pairs of prime number up to 100. So 17 is a prime number and 71 is also a prime number. So 17 and 71 is a pair like 13 and 31. And 17 and 71 are having the same digits, that is 1 and 7. Okay. So 17 and 71 is a prime number having the same digits, and 17 and 71 having two factors. So 17 and 71 are the prime numbers. So the first pair is 17 and 71. And the next pair is 37 and 73. 37 and 73 are prime numbers because they have two factors. So 37 and 73 have same digits. So these are the pairs like 30 and 31 and 17 and 71. Then the third pair is 79 and 97. 79 97. 79 and 97 are prime numbers and they have the same digits. So these are the pairs of prime numbers having the same digits up to 100. 17 and 71, 37 and 73, 79 and 97. Question number 4. Write down separately the prime and composite numbers less than 20. Write down the prime numbers and composite numbers less than 20. So, the prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17 and 19. So, prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17 and 19. So, 2, 3, 5, 7, 11, 13, 17 and 19. 2, 3, 5, 11, 13, 17 and 19 are the 19 and 19 are the prime numbers, less than 20. Also find the composite numbers that less than 20. And the composite numbers less than 20 are 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18 are the composite numbers less than 20. And the composite number less than 20 are 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18 are the composite numbers less than 20. So, 2, 3, 5, 7, 11, 13, 17 and 19 are the prime numbers less than 20. And 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18 are the composite numbers less than 20. Prime numbers means the numbers having two factors are called the prime numbers. So, these numbers are two factors, that is 1 and the number itself. And composite numbers means the numbers having more than two factors are called composite numbers, and these numbers are more than two factors. So these are the composite numbers less than 20. And the next question. Question number 5. What is the greatest prime number between 1 and 10? Which is the greatest prime number between 1 and 10? Question number 5. So, between 1 and 10, the prime numbers are 2, 3, 5, 7. So, the prime numbers between 1 and 10 are 2, 3, 5 and 7. And which is the greatest prime number between 1 and 7? 1 and 10 plus 7. 7 is the greatest prime number between 1 and 10. 7 is the greatest prime number between 1 and 10. So the answer is 7. 7 is the greatest prime number between 1 and 10. Here 2, 3, 5 and 7 are between the prime numbers between 1 and 10, and 7 is the greatest prime number between 1 and 10. And the next question, question number 6. Question: express the following as the sum of two odd numbers. Some numbers are given. We want to express the following numbers as the sum of two odd numbers. And the first number is 44. And we want to express 44 as the sum of any two odd numbers. Okay. So 44 is given as 3 plus 41. 3 and 41 are odd numbers, and 3 plus 41 we get 44. So 44 can be expressed in the term of sum of two odd numbers as 3 plus 41 is equal to 44. Then the next number is 36. That is 5. 5 is an odd number plus 31. 31 is also an odd number. So 5 plus 31 we get 36. And C 24. 24. Yes. Here 5 plus 19. 5 plus 19. 5 and 19 are odd numbers. Then add these two odd numbers we get 24. So we express 24 as in terms of odd numbers as 5 plus 19. 5 plus 19. Then D 18. So 5 is an odd number plus 13. 5 plus 13 we get 18. So 5 and 13 are two odd numbers. When we add the odd numbers 5 and 13 we get 18. So 44 is expressed in terms of the sum of two odd numbers are 3 plus 41 and 36 is 5 plus 31. Then 24, 5 plus 19, 18, 5 plus 30. Then the next question. Question number 7. Give 3 pairs of prime numbers whose difference is 2. Give 3 pairs of prime numbers. Prime numbers means 2, 3, 5, 7, 9, 2, 3, 5, 7, 11, 13. These are the prime numbers. 2, 3, 5, 7, 11, 13, etc. prime numbers. Here the question is, give 3 pairs of prime numbers whose difference is 2. We take any two prime numbers and take the difference, then we get 2. Okay, so if we take 3 and 5, 3 and 5 are two prime numbers. If we take the difference of 3 and 5, 5 minus 3, then we get 2. And another pair, 5 and 7. 5 and 7. 7 minus 5, we get 2. And another pair is 13 minus 11. 13 minus 11. Also, we get 2. So, these are the 3 pairs used to get the difference 2. Okay, so first pair is 5 minus 3, second one is 7 minus 5, and the third one is 13 minus 1. And the next question, which of the following numbers are prime? Here 4 options are given: 23, 51, 37 and 26. So the first one is 23. 23 having 2 factors, that is 1 and the number itself. Factors of 23 are 1 and 23. So 23 is a prime number. So 23 is a prime number and 51 is not a prime number. The factors of 51 are 1, 3, 7 and 17 are factors of 51. So 51 have more than 2 factors. So 51 is not a prime number. And the third one, C is 37. 37 having only 2 factors, that is 1 and 37 are the 43, 26, 26 are 4 factors, that is 2, 30, 21, 1, 2, 30, 26 are the factors of 26. So 26 are having more than 2 factors, so 26 is not a prime number. So the answer of 8th question is option A and C, that is 23 and 37. 23 and 37 are the factors of, so 23 and 37 are the prime numbers because they have 2 factors, that is 1 and that number itself. The question number 10. Express each of the following numbers as the sum of 3 odd primes. Express each of the following numbers as the sum of 3 odd primes. So, the first one is 21. 21 and the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, etc. And we want to express each of the following numbers as the sum of odd prime numbers. So 2 is an even number, we cannot use 2 here. Okay. So the first one is 21. 21. Which of the digits, which of the prime numbers are add when we get 21? That is the odd prime numbers 3, 5 and 13. 3, 5 and 13. 3, 5 and 13 are odd prime numbers. When we add 3 plus 3, 5 and 13, then we get 21. That is 5 plus 3, 8. 8 plus 13, 21. So, for getting 21, we use the digits 3, odd prime numbers 3, 5, 13, we get 21. 3 plus 5 plus 13 is equal to 21. And the next question is 31. For getting 31, we use the odd prime numbers 3, 5 and 23. 3, 5 and 23. 3 plus 5 plus 23. 23 is also a prime number and it's an odd prime number. These 3, 5 and 23 are odd prime numbers. When we add 3, 5 and 23, then we get 31. 3 plus 5, 8. 8 plus 23, we get 31. So, we use 3, the odd prime numbers 3, 5 and 23 for getting 31. And the question C, 53. 53. When we use 13, 17 and 23. 13, 17 and 23 for getting 53. 13, 17, 23. Here we get 53. So the odd numbers used for getting 53 are 13, 17 and 23. Question number D. 61, 61, 7, 13 and 41. 61. Find the sum of 61 by using the odd prime numbers are 7, 13 and 41. 7 plus 13 plus 41, then we get 61. Okay. This is the answer of question number 10. And question number 11. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. Write any 5 pairs of prime numbers less than 20 whose sum is divisible by 5. And the prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17 and divisible by 5. So 2 and 3 are prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers less than 20. These are the prime numbers less than 20. So we use any prime numbers from here and take the sum. Then we get the answer which is divisible by 5. So first we take 2 plus 3. 2 plus 3 is equal to 5. 2 plus 3 is equal to 5 and the answer 5 is divisible by 5 and 5 is a multiple of 5. And the next pair is 7 plus 13 or 2 plus 13. 2 plus 13 we also get 2 plus 13 we get 15. 15 is also divisible by 5. That is 3 5s are 15. And the next pair is 7 plus 13. 7 plus 13 we get 20. 20 is also divisible by 5. That is 4 5s are 20. And the next pair is 19 plus 11. 19 plus 11. We get 30. 30 is divisible by 5. And the next one is 3 plus 17. 3 plus 17. The next pair is 3 plus 17. When we add 3 plus 17, we get 20. 20 is divisible by 5. So these answers are divisible by 5. And the pairs, the prime pairs are 2 plus 3. Then we get 5. And 2 plus 13, we get 15. 7 plus 13, we get 20. Then 19 plus 11, 13. 3 plus 17 is equal to 20. And all the answers are divisible by 5. And the next one, so fill in the blanks question. Question number 12. Fill in the blanks. The first question, a number which has only 2 factors is called a dash. A number which has only 2 factors are called prime numbers. Prime numbers are having 2 factors. So the answer of first question is prime numbers. And question number B. A number which has more than 2 factors is called a composite number. Composite number having more than 2 factors. The answer of B is composite numbers. Question C. One is neither dash nor dash. One is neither prime number nor a composite number. One is neither prime number or composite number. Neither prime number nor composite number. And the next question. D. The smallest prime number is, prime number start from 2, 3, etc. So the smallest prime number is 2. Smallest prime number is 2. Then next question. E. The smallest composite number. Composite number start from 4. So the smallest composite number. The smallest composite number is 4. And the last question. Here. The smallest even number. Even numbers means the multiple numbers which is multiple of 2 is called are even numbers and it is the smallest even number. 2 is the smallest even number. So answer is 2. 2 is the smallest even number. So once again fill in the blanks. Question number A number which has only 2 factors are called prime numbers. Then a number which has more than 2 factors are called composite numbers. One is neither prime number nor composite number. And the smallest prime number is 2. The smallest composite number is 4. And the smallest even number is 2. So exercise 3.2 is over. And let's move to the next portion. And the next portion is test for divisibility of numbers. Test for divisibility of numbers. Okay. Let us see whether we can find a pattern that can tell us whether a number is divisible by 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the first one is divisibility by 10. Divisibility by 10. Divisibility by 10. Which means how can we find a number is divisible by 10 or not? Okay. So for an easy way, a number has 0 in its unit place, then it is divisible by 10. Unit place means its ones place. A number has 0 in its ones place or unit place, then it is divisible by 10. For example, here a number is given 280. Here in the unit place, 0 is a unit place. Then we can say that 280 is divisible by 10. And another number 368. In 368, 8 is a unit place. So 368 is not divisible by 10. Also, if a number having 0 in its unit place, then we say that number is divisible by 10. And the next one is an example 50. And 0 is in the unit place, so 50 is divisible by 10. And 100. Also 0 is its ones place, so we can say that 100 is also divisible by 10. Another example 1000. 0 is in its unit place, then we can say that 1000 is also divisible by 10. And the next one is divisibility by 5. The first one is divisible by 10. 0 is at ones place, then we can say that number is divisible by 10. A number has 0 in the ones place. 0 in the ones place. 0 in the ones place. Then we can say that number is divisible by 10. Then next one is, next text is divisibility by 5. How can we test divisibility by 5? That means how can we find a number is divisible by 5 or not? For that, a number which has 0 or 5 in its units place, then we can say that number is divisible by 5. A number which has either 0 or 5 in its units place or ones place, then we can say that number is divisible by 5. For example, 1,31,215. Here 5 is at the ones place, then we can say that this number is divisible by 5. So 0 and 1 is at the ones place. Sorry, 0 and 5 comes at the ones place, then we can say that number is divisible by 5. Okay. So we can test divisibility by 5 by a number which has either 0 or 5 in its ones place. 0 or 5 in ones place. Then we can say that number is divisible by 5. First one is divisibility by 10. So a number having 0 in its ones place, then we can say that number is divisible by 10. Then divisibility by 5. That means a number which has either 0 or 5 in its ones place or units place, then we can say that number is divisible by 5. And the next one is divisibility by 2. Divisibility by 2. A number is divisible by 2 if it has any of the digits at the ones place is 0, 2, 4, 6, 8. So a number having 0, 2, 4, 6, 8 in its units place, then we can say that number is divisible by 2. And the next third test is divisibility by 2. For example, 248. If this number is divisible by 2 or not. So we just look at the ones position in its units place. 8 is in the units place. If the digits are 0, 2, 4, 6, 8 are in the units place, then we can say that that number is divisible by 2. Here 8 is at unit place, then we can say that 248 is divisible by 2. And another example, 500. So here 0 is at the unit place, then we can say that this number is also divisible by 2. Here 3 is at the ones place, so we can say that this number is not divisible by 2 because 3 is at the unit place. So these are the easy way to find the divisibility of 10, 5 and 2. For find the divisibility of 10, if a number having 0 in its ones place, then we can say that number is divisible by 10. And a number having 0 or 5 in its ones place, then we can say that number is divisible by 5 or that number is divisible by 5. And if the digits at the ones position is 0, 2, 4, 6, 8, then we can say that number is divisible by 2. And the next one is divisibility by 3, that we will discuss in our next class. So you should study well and have a nice day. Thank you.